This is going to be a video showing how to do the problems on page 48 in your packet, making practice fun 40. We're going to skip numbers 13, 14, and 15, and we will be solving radical equations using inverse operations. You will absolutely need a blank sheet of paper to work. There is not enough room here, and you'll see that I've even on my work kind of made some extra space. Now, the first one has been done for you, so we don't need to worry about that. But the warm up for today is to think of what are the three things that happened to get from this equation to x equals 6. Hopefully you said square, then add 6, then divide by 7. And here's the reason. I can't add 6 until I get rid of the square root. It's like peeling an onion. I have to think, all right, well, what's that most outer thing happening? And most outer operation is the square root. So the inverse, because the most outer is the square root, the first thing I'm going to do is square. So for number 2, I have the square root of x plus 2 equals 5. What's the most outer operation? Like if I were to map this, I would map it x plus 2, square root of x plus 2, right? So like first I add 2, then I square root. So if I'm going to use inverse operations, the first thing I'm going to do to both sides to get rid of the square root is to square. So I'm going to square both sides. And now I have x plus 2 equals 25. And then to get rid of the plus 2, I would subtract 2. So let's see. And we get x equals 23, and that is letter R. Let's see. All right, number 3. I'm gonna cross these out so I don't forget which one is this. Number 3, we've got the square root of y plus 2 minus 3 equals 7. So again, this is the last time I'm going to map this out. If I took the right side of this equation where the variable is and I mapped it out, it would be y and then y plus 2, just like I was writing inverse functions, then the square root of y plus 2, and then the subtracting by 3. Just like if I was mapping out the function to write its inverse, I can solve an equation by kind of doing that same peel the onion technique. Take it off in layers. The outermost layer is subtracting 3, so I'm going to start by adding 3. Then I've got the square root of y plus 2 equals 10. I've taken care of this minus 3. Now I'm going to take care of the square root. I'm going to take care of that by squaring both sides. I'm left with y plus 2 equals 100. And obviously the last thing to do is to subtract 2. We get y equals 98. That is, I see it down there, is letter T. All right, number 4, we've got the cube root of x minus 5 equals 3. I only have 2 operations happening here. The inside is the subtraction, the outside is the cubing, the cube root. So the first thing I'm going to do is cube both sides. 3 times 3 is 9, times another 3 is 27. And I'm going to add 5. And we've got x equals 32, which is letter H. Number 5, we've got the square root of x plus 4. And again, you should really be doing these on your own and using the video as a resource to check or if you get stuck. I see the outermost operation is subtracting 19. So I'll start by adding 19 evenly on both sides. So this is going to be, oh, good. I see. Okay, I want to point something out. I was just like, oh my gosh, I really do not want to square 35. But then I looked back and I recopied the problem wrong. Most of our mistakes happen from little things like that. That is much better. 35, ooh, that would have been ugly to square. But now I'm just squaring 3, and that's not so bad. So if we square both sides, we get x plus 4 equals 9. Subtract 4 from both sides, we get x equals 5, and that is letter I'll say, oh, there it is, O. I'll get it. I said, uh-oh, and it was O. That's kind of funny. Back myself up. Number 6. Now, this one's going to be a little different. I have 3 square root of x equals 9. Now here, it's not the square root of 3x. Like if I were to map this out, it's x and then the square root of x and then 3 times the square root of x. So the first thing I'm going to do to get rid of this times 3 is divide by 3. And then I've got the square root of x equals 3. And then when I square both sides to get rid of the square, I get x equals 9. I feel like that's a little strange that it's 9 again. Let's take a look at number 7, because number 7 is a similar situation. So after you write down number 7, think about what 2 operations we're going to do and like be specific about order. If we have 5 root x equals 35, how can I solve this? All right, hopefully you thought to yourself, first thing I'm going to do is divide by 5. And then I get the square root of x equals 7. And then square both sides. We've got 49. Okay. I'm going to, because I have a magic problem here. Well, I don't want to move it to the annotations, won't move. Number 8. All right, number 8, we've got the cube root of x minus 3. Ooh, that made that way too long. Plus 9 equals 7. Now, again, I'm thinking ahead. The last thing I'm going to do is add 3. Then in the middle, us cube. And so actually the first step is to subtract 9. Now, normally when I would have a root and there's a negative number over here, it would make me a little skeevy. But then I'm like, whoa, it's a cube root. I can take the cube root of a number and get a negative number. That is okay. But if this was a square root, I would be stopping right here and being like, no way, Jose. That's not going to work. No, absolutely not. Nope. But I can cube a -2 and get -8, and everything is good. So I have x minus 3 equals -8. And I end up with x equals -5. -5 matches with A. Open another copy of this one to keep scrolling up. That's annoying. Number 9. I'm going to open another copy. You have a copy of this, so it's not a big deal. All right, so number 9 is 7 equals 1 over the square root of x. And if I were to ask out of all the problems on this page, which one do we need to talk about? Number 9 probably would get the most votes. Number 9 is a little weird because it's 1 over x, and people don't really know what to do with that. So I want to think about our mapping strategy. If I were to map the right side where the variable is, first I would take the square root, and then I would take the reciprocal. Right? That's what's happening here. Square root, then reciprocal. So to solve, what's the inverse of taking the reciprocal? Taking the reciprocal. So I'm going to make this 1/7 equals the square root of x over 1, which is just the square root of x. Another way to approach this would be to cross multiply, but I like this strategy a little better. I think it's a little more straightforward. It saves us a little time. Again, I take the reciprocal of 1 over x, it takes me back to the square root of x. Then I just need to square both sides. Squaring 1 gives me 1, squaring 7 gives me 49, and that is letter P. All right, number 10. I'm going to do number 10 over here because I have space. Number 10, 48 root x equals 6. I'm going to divide both sides by 48 to start. And this is going to mess some people up because there is a fraction that needs to be reduced. 6 and 48 are both divisible by 6. If I divide them both by 6, 6 divided by 6 is 1, 48 divided by 6 is 8. Now I'm going to square both sides and I get x equals 1 over 64, which is letter I. Now we are going to do number 11, and number 12, but then we are skipping 13, 14, 15, just as a reminder. So number 11. Number 11 is the square root of 3y. Ooh, that came out so ugly. That's a little better. Equals. So this problem we are going to approach differently than 1 to 10. 1 to 10, we were able to think about the equation, think about the side with the variable, map it out in our head, apply inverse operations. Here, I have variables on both sides. I can't do that, but I noticed that both sides have a square root. So I'm going to start by squaring both sides to cancel that out. Now I have variables on both sides still, but it's more like an algebra 1 problem. There are lots of different approaches. I'm going to start, I always like to move the little variable because the big variable is in charge. Like in my head, I think the 3 is in charge. So the 1y is going to come to him. Then I'm going to add 1 to both sides. Now it's not a big deal. I've got 2y equals 14. So obviously divide both sides by 2. Y is 7, and that is letter N. All right. The last one I'm going to do all the way out is number 12. The ones at the bottom I'll do, but I'm not going to like walk through them in depth because at this point I feel like we're still struggling with 16 to 18. You and I probably need to eat lunch together on Monday, or the next day if you're watching this video on Monday. No, you're watching this video. Whatever. Wait, Tuesday? Yeah, Tuesday. I'll see you tomorrow at lunch. Okay, so number 12, we've got 2 root 1 minus 2x equals the square root of 4x. Now we are going to apply the same strategy we did in number 11. We're going to square both sides, but look what I'm doing in red. So I put parentheses here. I need to square everything on the left. So when I square, I need to square the 2 and I need to square the root. When I square the 2, I get a 4. When I square the root, I'm going to get 1 minus 2x. And here they just cancel. Now I'm going to distribute the 4. I could also divide it, but I'm going to distribute 4 minus 8x. Now this is a bigger number, but it's negative. So I'm going to add 8x to both sides. There's a number of ways you could do this. You will still get the same answer that I will. I have 4 equals 12x. I'm going to divide by 12 and I get x equals 1/3, which is letter Z. Now we are skipping 13, 14, 15. Again, like I said before, 16, 17, and 18 should go pretty smoothly. I will do them here, but I'm not going to like do them slow. So let's see. Uh-oh. Oh, oops, I'm stupid. That's an 8. 9. Subtract the 8.